All right, let's take a look at the organs of the male reproductive system. So here we're going to start off with the testes. The testes are the primary reproductive organs of the male. So they're the primary reproductive organs of the male because they produce sperm cells and they also produce testosterone. And they are contained within the scrotum. And we'll get to the reasons why here in a little bit. Now if we look at the structure of the testes, as shown inside there, we have a tunica albuginea. So the tunica albuginea is a tough, white, fibrous capsule that surrounds each gonad. We're going to see this around the ovaries as well. Next, within here, we have these seminiferous tubules. So the seminiferous tubules are small tubes within the testes where sperm cells are made. All right, so this is shown over here, cut through there so we can see inside each one of these things is seminiferous tubules. So lots and lots and lots and lots of sperm cells are made here. All right, these are going to unite here at what is known as the rete testis. All right, now in between, you're seeing these cells that are in between those seminiferous tubules. Those are called the interstitial cells. And those interstitial cells are going to produce and secrete the male sex hormones, testosterone. Okay. If we take a look at the structure of, so this is just another picture of a seminiferous tubule. Those are the interstitial cells. We go to the next picture here. This shows a sperm cell. What we see with the sperm cell has a head part to it, right? And that contains a nucleus with 23 chromosomes. The top of that is an acrosome. So the acrosome contains, so on the anterior end of it, it contains enzymes that aid in penetrating the egg cell. Next is the midpiece. So this is a blow up of the midpiece right there. The midpiece has many mitochondria in there, and those are going to provide energy for the tail, right? So they're going to break down energy molecules, allowing that tail to move. All right. And the tail is flagellum, and it provides movement for the cell. All right, let's look at the descent of the testes. Now, the testes actually begin their development near the kidneys. In about 1 to 2 months before birth, the testes are going to descend into the scrotum. All right, so testosterone is going to stimulate their descent. And so you're seeing this little cord right here, and that's called the gubernaculum. So there's a fibromuscular cord that guides the movement of the testes into, into the scrotum. Now, if we go back a little later here, there's the testes within the scrotum, and then the scrotum, or the gubernaculum, anchors those testes into the scrotum. All right? So, if somebody has cryptorchidism, that is a failure of one or both testes to descend into the scrotum. And so, if somebody has that, one of the problems here is if the testes don't descend, the male is infertile. Because body temperature is too hot to produce normal sperm. All right. So if somebody's testes don't descend, they stay in the abdominal pelvic cavity, they're going to produce abnormal sperm and lower amounts of sperm. All right. But being in the scrotum outside of the body, this lowers the temperature of the testes about 5 degrees to about 93 degrees. So next is looking at male internal accessory organs. So looking at these, so on the testes here, so that is the epididymis. So this is a tightly coiled thread-like tube that collects the unmatured sperm cells. If we go back to this picture here, this is the epididymis right there, and as you can see, it's a tightly coiled structure there. All right, this is where the sperm cells are going to mature. All right. It's going to secrete glycogen for the sperm cells. So glycogen is storage form of glucose. So it's long chains of glucose molecules. All right, and so the sperm cells, because they don't have a lot of cytoplasm on there, can't really store energy molecules. So we're going to see a couple places where organs are going to release energy molecules for those sperm cells. All right. Sperm cells are moved throughout the entire male duct system through peristaltic contractions. So let's get back to this picture here. Next is the ductus deferens, so you can see it coming up and then looping around. So the ductus deferens is a tube that transports sperm from the epididymis to the urethra. All right, and it ends in a little enlargement called ampulla, which is really hard to see on this picture. and it's going to unite with seminal vesicles. Now this is a seminal vesicle. Now the reality is the ductus deferens doesn't come into the top of the seminal vesicle. The seminal vesicle is actually kind of off to the side. But they're going to unite together and they're going to make this tube right there within the prostate gland. So that tube right there is called the ejaculatory duct. Now let's move on to the seminal vesicles here. So the seminal vesicle there, all right? So these are sacs that secrete an alkaline fluid with fructose and prostaglandins. So fructose is used for energy for the sperm, all right? It's alkaline because it's going to neutralize acidic metabolic waste from the sperm and also acidic secretions from the vagina, which we'll get to there when we get to the vagina. And lastly are prostaglandins, and these are going to cause muscular contractions within the female reproductive organs. All right, so that's going to help transport the sperm to the egg. Next is the prostate gland. So there's a prostate gland right there. So this is a gland that secretes a thin, milky, alkaline fluid. It's alkaline for the same reasons that we talked about the seminal vesicle secretions being alkaline. Next is urethra. You can see the urethra goes to the prostate gland. Not a good design here, all right, because if that prostate gland were to enlarge, it's going to close up that urethra. So it goes through the prostate gland, and then all this is through the penis. So, so we talked about the urethra with males. It not only transports urine, it transports sperm and reproductive fluids. Next is a bulbourethral gland, found right there. There's a bulbourethral gland. And so this is a gland that secretes a fluid that lubricates the end of the penis. All right. It also secretes an alkaline fluid that neutralizes residual urine that may be in the urethra. All right. Lastly, what is secreted here is semen. And this is a fluid that the urethra transports out of the body during ejaculation. So this contains sperm and secretions from the seminal vesicles, prostate gland, and a little bit from the bulbourethral gland. So this can be anywhere from 2 to 5 milliliters of volume of fluid, and that fluid will contain anywhere from 75 to 400 million sperm per milliliter of fluid. Sounds like a little bit of overkill because all you need is one sperm to get to the egg. But let's go to the female reproductive system and talk about why so much are produced here. So, sperm are dropped off here in the vagina, all right? And so a lot of them will not even make it into the uterus. So this is a uterus here, there's the cervix, essentially the opening. So here, all of these are moist environments, but they're not fluid-filled. So the sperm actually are swimming in the reproductive fluids that are secreted from the male, right? So they can only move so far before they run out of fluid that they're surrounding themselves with. And then the sperm behind those will move a little further until they run out of fluid and so on, all right? So this is trying to show you that this is a team effort to get some sperm to the eggs. Oh yeah, by the way, some will take the wrong turn at Albuquerque here, so going down to the wrong side. So by the time we get to the oocyte here, we only have about a few hundred sperm making it there. And in fact, if an individual produces less than 50 million sperm per milliliter, that guy is considered to be infertile because he doesn't make enough sperm to actually get to the egg.